And before we start working on the warm-up problem, I just want to draw your attention over here to the fact that there is some homework, okay, that you'll need to do for tonight. So if you want to write that down right now so you don't forget, so you don't miss it, it's chapter 2, page 45, questions 1, 2, 5, and 6. If you are here over Liberty Time and you want to come in to borrow a book, you can borrow a book and take it to your Liberty Time and then bring it back. That's totally fine. You know also that the book is available on Canvas. And if you go to the top bar, you should be able to click on that little bar inside that window and type in page 45. Okay? If you have any issues or questions about that, send me an email. I'm super happy to help you out, but it should be pretty straightforward. Do you have a question? Or was I dreaming?
I was going to ask if I could go take a picture.
You absolutely can. Can we do it then in the class? But yes, absolutely you may. Yeah. All right, so we're going to work on this warm-up problem. Hopefully you've started it a little bit already. It asked for you to draw a best fit line and then determine the slope of the graph. So what did you do? Can you get me started? What was the first step that you took in that process? Yeah, go for it.
I found the one that crossed first, the lowest one that crossed first.
Okay.
And I tried to line them up from there and the other ones still have specific.
Okay, so I'm going to repeat that really loudly so we can talk about it. Is that okay? So she said that she found a place where the data point crossed. It just happened to be that first point. Friends, I'm going to ask for your full and undivided attention up here, please. Thanks. Full and undivided attention up here, just so we can make sure we're all in this together. So you picked this one because it was on a grid line, and then just kind of lined that one up with the other grid line points. Can I ask a question? Just out of curiosity, and I just want to kind of dig in here. What if that first point had been down here? Or had been like way up here? Would that process have worked for you?
No, but I still don't try to line it up as best as I could. I started on there and then get them across the rest of it.
Got it. So you would kind of want this point to be part of your story? Is that what you're saying?
Yeah.
Yeah. And I'm not surprised at that because I think a lot of people want to do that. To make that first point, maybe that last point, kind of make those part of the line. I want to show you though. Thanks.
I actually got a different way you could do it.
Oh, go for it.
What I did was I, lined it up so there's an about even number of dots on above, below, and within the line.
That's fantastic. And that's
So
kind of
what I did is the two middle dots because that would make it 2 dots above, 2 dots below, and 2 dots in.
Okay. So you took these two. I'm going to erase the red ones because I'm going to get confused otherwise. So, Dimitri, let me make sure I'm understanding what you're saying here. So you're saying that you took these 2 middle dots here, okay? So if you do that, if we connect those 2 dots, then you definitely have a couple of dots above. Do you all see that? And a couple of dots below the line. And by above and below, I mean above that angled line, okay? Is that, I think that's a good approach. I think we've got lots of good ideas. Is that going to be a line that most completely fills all of the data? What do you guys think? Shaking your head. What would you do? Not that?
No, the other way.
If we tip it like this, so that we can get a little bit, I like, Dimitri, what you're saying about getting some that are above and some that are below. Yeah, and I think incorporating as many of the points as you can is really important. But it's important to not try and follow too much of a prescriptive approach because it might give you the wrong answer. So,
But isn't science all about prescriptive approaches?
It is, but I guess let me tell you the prescriptive approach I would take. Is that okay?
Okay.
So there are mathematical ways to do this, and computers do this all the time. You may have even done some data analysis in chemistry where you used a computer to get all of that data. So you may or may not have, but the game is, it's kind of more of an art than a science in this case. We're going to tip our best fit line so that you do have some above and some below, okay? Not every single one of those dots is going to fit on a line, and that's okay, okay? But you want a little bit above and a little bit below, and you definitely don't want to connect those dots. Does that make sense? I'm going to write a couple of these ideas down, and I would encourage you to do that either on your little piece of paper if you're positive you're going to hold on to that little piece of paper forever, or, for like the next couple weeks. Or go ahead and get some notes out. Some notes that you can write on, okay? Some paper that you can write on for some notes.
So what's the best line of fit you just put?
I'm gonna do it in just a second, Dimitri. Hold on just a sec, okay? So let's write down a couple of things about a best fit line. It is the 3rd of September, yep. So a couple of things about a best fit line. What's that? That it's already September? Yeah, right? One thing to note about a best fit line is that you should not connect the dots, right? That's a no-no. We are already aware of that. But let's write it down. Do not connect the dots because they wouldn't even be in a straight line. Well, we're getting there. Hold on. We'll do one thing at a time. Instead, you're going to place your straight edge, okay? Such that you have as many points going through it and a balance a little bit below and a little bit above. So place the straight edge so that points are either on the line or just a bit above or below. And we want to get as much of a balance as you can of points just a little bit above or below. Assuming that there isn't an outlier. Like, for example, if I had a point like way up here, this red dot, that definitely doesn't follow the trend. Are you with me there? So we're going to leave that point out. That would be an outlier. We put a little X over it. Say, see you later. We don't like it. Okay? So I'm going to take my straight edge, and I'm going to try and line it up as best as I can above and below, so I've got as many points incorporated or close as possible. But it doesn't have to be exactly through the bottom point. It doesn't have to be exactly through the top point, and it doesn't have to be exactly in any point, in fact. Okay? But you're trying to get a straight line that matches up with as much of that data as possible. Okay? The line does not have to go through any of those points. Does it look? That's great. Yeah. And it's a little bit, like I said, it's a little bit of an art. And as we move forward, then your line might not be exactly like my line. Your line might not be exactly like your neighbor's line, and that's okay. As long as the process is working, that's what we're paying attention to. That's what we're concerned about. Okay? Do you notice something else that line of best fit does not go through? Take a look up there. Talk to your neighbor. Talk to those people around you. Do you see something else that it doesn't go through, kind of maybe surprisingly? Talk to your tables. Have a conversation quick. Did you guys come up with an answer? Yeah. So Rachel, do you want to tell us what it was?
I hear whispering.
Yeah. The origin. Did I hear other people saying the origin?
What's the origin?
The origin. That's a great question. What is the origin? The origin is right here. The origin is 0, 0. Okay? Now, quickly, before we make any gross overgeneralizations, let's think about this data. I will tell you that this data came from a bowling ball lab that we did last year. The same process that you guys did last week. I did this last year with my students. I've done it, for decades, which is kind of frightening to say. But I've been rolling balls down hallways for a long time. So this data came from last year.
Rolling balls down hallways.
I mean, that's what we do. Now, let's think about.
When you put the S
let's-
on the end.
Let's think about the process. When you were out there, we had that ball that was rolling, and when did you start your stopwatch? Do you remember? She said start really loud, right? Start! She said start really loud, and then all of a sudden, you all started your stopwatch, which meant that it was at what number when you pushed the start button? It was at 0. And that started at exactly the 0 point. Are you with me? So it had gone a distance of 0 meters when the time was 0. So it would make sense, in this case, for this line to go through the origin. Can you guys put your computer away? I don't think you need it to yet.
But then why doesn't it?
It's almost as if I had paid him to ask that question. Why doesn't this data go through 0, 0?
You didn't pay me. I can put that out there right now.
It was just well timed.
Pay me.
I didn't. There was no money exchange there. Why doesn't this line go through 0, 0? Any ideas? Do you want to talk to each other for a second? Have a conversation. Why do you think? Because the line clearly doesn't go through 0, 0. Why not? What possible reason might there be? Do you guys have an idea? All right, let's come back. Any ideas why that doesn't go through the 0, 0 point? Through the origin?
I'm clueless.
Yeah. Does I have a pencil up? That's harder, yeah? No? No? No ideas? Well, it should. Let me ask, when you guys were out there last week, those of you that were holding the stopwatches, were there any situations in which you may have not quite gotten your stopwatch started at the right time?
Yeah.
Is that possible? I'm sure that some of you didn't make any mistakes. But I'm also sure that most of you probably made mistakes some of the time. This data should be skewed this way a little bit, right? But maybe there were some errors in this data that caused this line not to go through the 0, 0 point. It's important to know that, okay? And it's important, as we've been kind of saying, but I want to make sure we've got it written down, okay? That you do not
That's why we need
force
computers doing our stopwatches.
the best fit line to go through the origin. In fact, forcing it does not acknowledge that there might be error, okay? I'm going to say a y-intercept. Do you guys know what I mean when I say y-intercept? Using all kinds of math terms that you may or may not have used lately, okay? The place where the line crosses the y-axis. The y-intercept not equal to 0 means that there was some error in the data. An error is fine as long as you acknowledge it and you know that it's there. Okay? So that's what we're saying. The y-intercept not being 0 means that there was error in the data. That's okay. We don't want to force it to go through that point. Okay? Never ever. So when you're taking some data, I don't know, later this week, next week, whenever that is, if your line of best fit doesn't go through the origin, that is okay. That gives you something to talk about in your conclusion. Right? That gives you an opportunity to have some science. That's great. Okay. Yay for us, drawing a best fit line. Woohoo! What are we doing next? What did the next part of that instruction say? Not only to draw the best fit line, but also to find the slope. Do y'all know how to find slope? Maybe. It's been a while, maybe? Let's write some stuff down. Look at you all reciting your linear equations. What letter do we use for slope? M. Yep. And how does one find the slope of a line? I heard somebody.
Rise over run.
Rise over run. Yes. Yes. Rise over run. So I always, whenever I heard that, I was like, I don't really get what that, I mean, I get what it means, but I always find it kind of funny. I like equations. I like places to plug numbers in. It makes me feel more like I can do it, right? I'm like, rise over run, what's that? What does rise over run mean in numerical form? Yeah. Bam. Yep, it's a change in y, right? So I'm gonna do y2 minus y1. Is that okay? That's exactly what you were saying, Mike. I totally agree. So it's y2 minus y1 over x2 minus x1. You could also write it as delta y over delta x, but I don't want to freak anybody out yet. So here we go. Okay?
y2 minus y1 over x2 minus x1.
You got it. Exactly. So in order to do this, in order to find the slope, we need 2 data points, right? I just said the wrong thing. Kind of embarrassing. Ignore that I just said that.
Said
In
what?
order, right? Exactly. In order to find the slope.
Asking, said what?
I said, are you listening? Because I don't want to say it out loud because nobody else will hear it again. I said data points. But that's the wrong thing to say. So now that I've got your attention, it's not data points. In fact, I'm going to write that down because it's so important. When you're finding the slope, do not use data points. Don't do it. Don't do it. Ever, ever, ever. Do not use data points.
I think that's the bell.
That was the bell for the other lunch. We got time. We got time. So if you can't use data points, what are you going to use? We're going to use points from the line. So we're going to look carefully. This is the hardest part of the process, so make sure you're paying attention. Your line might not look exactly like my line. Okay? It might, but it might not. But what you're going to do is look carefully at your line and find places where your line crosses the grid lines very nicely. So for example, I'm looking at my line and I see one, sometimes it's hard to find them. I see one right here. And then I see another one right here. And I would strongly encourage you, I feel like there's a lot of chatting and I want to make sure that I've got your attention so you understand this. I would strongly encourage you to put an X on those points that you're going to use to find your slope so that you don't confuse them with data points. Some people like to circle them and that's totally fine too. But you only need to find 2. Okay? Figure out what the coordinates of those points are and then calculate the slope. Okay? Because your line might not match mine, I'm going to let you do that right now. I will do it too, and then we'll compare in just a moment, okay? So go ahead and get started. If you're stuck, you're not sure what to do, then ask your table mate or ask me, and I will absolutely help you out, okay? Go ahead and get started.
So would it be meters per second?
It will be, yes.
What's the points? Because I noticed one isn't 1-to-1 ratio.
It isn't. So you'll need to. So if we look carefully, it's 1, 2, 3, 4. So each one is a quarter of a second, and I think these are also a quarter of a meter. That's what it looks like to me here. So that's 0.25.
Or like what? 0.35?
So it would be like 0.25, 0.5, 0.75. Does that make sense? Thanks for asking. I appreciate that. So everybody should be working on this. Absolutely fine to talk to each other if you need help. But use the points on your line, not on my line, because your line might not match mine. Oops. So friends, this is your opportunity to master this or to try it out for the first time, and then we're going to master it soon.
The X is left to right, right?
X is left to right. It's the horizontal. Yes, correct. So friends, I want to make sure that you write out the process just like I did in that blue box up there, okay? I want to be able to see exactly what you've done so that I can follow along and double check, because your number might not match mine, and that's okay.
Can I have a calculator, please?
They are right next to you on that table. You see everybody?
I'll have to get used to that.
Yeah. It's hard to see, of course, yeah, anytime.
I just developed minus 20. Then when I realized my method wasn't very accurate, I did another line.
Awesome, good for you. That's cool. I love that. Question? Okay, it was like a dance. Roach with a TH. Yeah.
I'd sure like growth in my amount of money I have available. After all, I don't got any.
All right, my friends. I am super excited with the success that you guys are having. If you're struggling a little bit, please let me know. I want to help you get this. I know that you can, okay? So you see up here in the blue box that I got 1.05. Did anybody else get 1.05? That's okay. So I've done this 3 times. So I did it second period, third period, fourth period. The first period I got 1. The second time I got 1.07, and then I got 1.05. Moral of the story, because I know that I'm doing good physics each time, right? The moral of the story is that it really depends on how you draw your line, okay? So as long as you draw your line carefully, and your line looks reasonable, and as long as you find points, and then follow through in the appropriate way, it's fine. So I would say that if you got an answer that's somewhere between 0.7 and 1.3-ish, we'll call that a win, okay? If you got something that's like 2 or 17, then that might be a problem, okay? So then you have to be a little bit more careful, and let's go back and check. But as long as you got something pretty close, we're good. Okay? There's one more step here that we have not done, and I want to make sure we do. And that is that we haven't really looked at the units. Now, you may or may not have heard the spoiler alert that came from over here, but I want to make sure that you all see where this is coming from as well. Okay? So what are the units of the 5.5 and the 0.75 that I have up here? They were values that were over here. What are the units on that top? Meters. What about on the bottom in the denominator? Say it with confidence. Seconds. Yeah, seconds. You got it. You guys can do this. Believe in yourselves. You got this. Meters on the top, seconds on the bottom. And oh my gosh, we're dividing meters by seconds. So the units for this value here, what are the units of this 1 or this 1.05 or whatever it is?
Meters per second.
Bam. You got it. Meters per second. And because you're clever and because you've heard this unit before, my next question for you is, the slope of this line represents what about that ball? What does meters per second mean? What is it? Say it loud.
Speed.
Yeah, it's the speed. It is. It's the speed of the ball. We're going to write that down too because that's important to know. So we're not going to use data points. We knew that. We're also going to write down that the slope of a distance versus time graph is the speed of the graph, or the speed of the ball, of the object. That is not trivial. That is important. Do you guys know what the word trivial means?
I'd say not important.
Trivial means not important. Has anybody ever played Trivial Pursuit, the game, the board game? Yeah? I am not good at Trivial Pursuit. My husband is really good at it. Why? Because he knows a lot of random stuff. Trivial means random. Like, how many of Edgar Allan Poe's great nephews played on the 1942 Notre Dame football team? It was something like 12. It's something like I don't know. He knows that now because we got that question one time and it's really random. It's random. This is not random. This is not trivial. That means it is important. That's what we're talking about here. The slope of a distance versus time graph is the speed of the object. Okay? On Friday, we had our bowling ball data out, and we actually started doing some of this. What I would like you to do right now is to determine the speed of the fastest trial that we collected, okay, or that we graphed. Determine the speed of the bowling ball during the fastest trial that we graphed. Okay, so you need to get that out. Give it a shot. I think you can do it. Give it a shot. Talk to each other. Work together. You can absolutely solve that problem.
The fastest point we all grab?
The fastest trial that we did. So you have to determine first if it's G, D, or M. And then find the slope of that line. There you go. There you go. All right. If you were not here on Friday, just find a buddy that was and work with them. That's absolutely fine. You don't need to start from scratch. Okay? Find the slope. Find the speed of the fastest trial that we did on Friday.
What if you yourself don't have a graph for G?
Oh, that is a good question. You can go ahead and do the other one. And I'll do a post so we can double check. Do you still have it from yesterday or from Friday?
This one.
Do you want to just keep moving? That's absolutely fine.
Six blocks. Yeah. For the. So what?
So to be clear, which trial are we doing? G, right? Okay, I just want to make sure everybody's happy with that. Don't want to make anybody feel bad. I just want to make sure that we're all together. All together now. And sometimes you have to kind of estimate, and that's okay too. You are not stupid. You're having a moment where you need to just take a deep breath, right? Yes. I 100% understand. I feel for you because I do that all the time too. I just want to make sure that you're using positive self-talk. You know what I'm saying? It makes a difference. Oops. How do we do? Just G.
Yeah, I was, but I just have to work as a team. You're not really working together. Although I'm pretty sure that if my points were another kind of wiggle to.
So Randy one up here and Randy one down here. What is your name?
What's the elevation?
Mine was really close.
Excuse me.
So there's a college. It wouldn't be like
Excuse me.
The positive?
Yeah.
My friend's right here. What's up, babe? All right, physicists, you guys are doing awesome. I love it, love it, love it. I want to spend, we've got about 10 minutes before the end of the period. And in those 10 minutes, we need to define 4 words. Okay? So on your notes, find a space that's at least a third of a page big, I would say. Did I talk to you about notes already or no? I can't remember. Did we talk about this? Just like today? Okay. I talked about it in the other class and I couldn't remember if I said it in here or not. So I know that in other science classes you have gotten like guided notes sheets. I don't do them. So if you hate them, then high five with me, right? If you love them, and if you feel like that's all you know, it is time to break free. Okay? Now, a couple of things. I'm not going to just leave you out in the middle of nowhere, okay? Everything that I want you to write down, I write down up here. So I'm modeling what I want you to do, okay? If you have a situation, whether it's diagnosed or not, but you are not able to take notes, or it doesn't work for your brain, or you're just having a really lousy day and you can't focus on getting stuff written down, then if you send me an email, I can easily save this as a PDF and send it to you. Like super easy, no problem. Okay. And I also do record all of the lessons. So you've got access to that as well. Okay. But that all said, we are going to take some notes today. And I would encourage you to set it up in the way that I'm going to write 4 words down. Here they come. All right, friends, we don't have a lot of time, so I need to have your full and undivided attention up here right now. You've probably heard these words in life, okay? We defined speed already. We kind of defined that when we were finding our slope earlier today, right? What is speed? What is it?
How fast you're going.
How fast you're going, right? That's awesome. Let's write that down. It's pretty easy to kind of conceptualize what speed means. We kind of wrote it out, but not officially, a little formula for it. We can say that speed is really kind of like distance over time. So what's distance? What does distance mean? Not a trick question.
How far you go.
Does that make sense to you? How far an object travels? Sure.
So speed was what? Like the formula?
Speed equals distance over time. So how far an object travels. Have you heard the term displacement? Maybe in this kind of context or maybe in some other kind of context. What do you think of when you think of the word displacement? Water. Tell me why.
Because when you put something in the water and the water rises, because it's displacing the water.
Awesome. Yes. Did you guys all hear what she said? Let me say it loudly just in case. So if you have a container of water, like I'm thinking like a beaker or a graduated cylinder, right? And you put an object in it, then the water level rises because the water is being displaced by the object. Okay.
Maybe all the boats we're putting into the sea is contributing to the rising sea.
I don't think that appreciably changes it, but good thinking. Displacement means like moving something, right?
Did you realize that there's a trash island in the ocean?
I did realize that, my friend.
It's the size of a continent.
It's terrible, yeah.
Yeah, it's the size of a continent.
So
You'd think that would raise the sea level.
All right. Displacement means change in position. If you talk to anybody, random people on the side of the road, and you talk to them, maybe not on the side of the road, walking down the pet mall, I feel like that would not be a good conversation to have, right? But if you're walking around the pet mall, you just walk up to somebody, hey, what's the difference between displacement and distance? They'd be like, nothing. It's like the same deal. But in physics, it does matter. Let me show you why I think so. I'm going to put 2 points here, A and B. And 2 different objects or people or whatever that travel from A to B. One's going to go like this. Okay. The other one, oops, it started at A. Sorry, but stylus didn't work. Let me do that again so that you'd believe me, because I don't want to, confuse you all. Okay. The other person goes that way. Did they travel the same distance?
No.
No. Right? If you think about it, like the number of steps that they did, the blue person went a lot further, right? But tell me about their change in position. It's the same. So the distance is how far an object travels. You could think about that as like the number of steps that they take. Or like your odometer on your car that counts the number of miles that car has traveled. Whereas the displacement, well, tell me about the displacement. Same, right? It doesn't matter how you get there. It is path independent. So path does not.
I'm going to go DT for distance and DP for
Displacement? Cool. I'm going to make it a little easier for you even, Dimitri. We are almost never, ever going to use distance. Almost all of the time in physics, we are going to focus on displacement. And I'm going to write it down another way. Displacement is a change in position. So I'm going to write it. Do you guys know what the Greek letter for change in is? It's the triangle one. Anybody know what it's called? Delta. Delta means change in. Delta X means change in position. It means like final minus initial. Final minus initial gives you the change in position. That is the displacement. Even more so than distance and displacement sounding the same. Again, if you walk up to random people in the ped mall or whatever, and you ask them about the difference between speed and velocity, most of them are like same, right? Nothing different. But as scientists, we know that velocity is a little bit special. Does anybody know a new definition for velocity or something that keeps it a little unique? Yeah, go ahead. You're close. You're going one step further even. Hold on to that for a couple days. Anybody else? Velocity? Mm-hmm. Velocity is speed with direction, is usually how people think of it. And we'll talk more about what that direction thing means. But the thing that I want to make sure that you get written down right now is that V, that's the letter we use for velocity, V is equal to the change in position, or the displacement, divided by time. Okay? This right here is a super important equation to write down. This equation is actually the first equation on your equation sheet in the top left-hand corner.
Excuse me.
Yes?
Can you read what it says there?
Here or here?
There.
This one says speed with direction. Yeah. I'll put them up. Is that okay? Yep. If you needed to get the homework, it's right up here. Page 45, 1, 2, 5, and 6. Work on those tonight. We'll go through them tomorrow, okay? Have an awesome Tuesday, friends. It is, yep, it's on, it's all of this. Okay, yep, if you can't find it or whatever, send me a message. Yeah. Thank you so much for putting my rulers back. I appreciate it.